We are back at it again, Twinsburg High School Algebra 1 people. Today's lesson is going to be exponential functions. If you notice, it says day 1 because this is going to be a 3-part series. Today's lesson is going to be basically getting the meat for the equation itself. So we're going to figure out like what each and break it down, what each part means. Sit back, relax, and enjoy the ride. Here we go. Boom. All right, today's objective, you will be able to define the exponential functions. You will be able to graph exponential functions. You will be able to determine if an exponential function is growth or decay. So growth obviously means the numbers are getting larger. Decaying means it's going to be getting smaller. Exponential equations. We talked about this when we talked about functions way back when. However, if you forgot, we had linear functions, we had quadratic functions, and now we're going to have exponential functions. Linear, remember, they all went up by a constant amount. That was going to be that first difference, which was linear. The second difference was quadratics, where we had to take the y values, and so nice we did it twice. And then exponential was when we were multiplying to get that common difference, all right? So if we look at it, a function whose input x is located in the exponent. So what does that mean? Right here, y equals a plus bx. So a plus bx. If you notice again, you're going to have that exponent be your input value. Again, what is solve for? What is all by itself? That output, the y, and then we have, let's just go to the next one, the initial value, which is also going to be called my y-intercept, which was b in linear equations. However, with the exponential, it's going to be that initial value is the y-intercept. So this is going to be important. And then b is the multiplier. How are we going to change? All right. Is it going to be growing, that growth rate, or is it going to be getting smaller, that decay rate? All right. So again, that initial value is the y-intercept, which is going to be crucial for our success when we look at 1, the graph, and 2, tables. Exponential equations, just to give you an example, Jason has $17 and quadruples. So you can see that some of our vocab is going to be key to our success here in this section. Quadruple means 4 times the amount, so that's going to be our multiplier of 4. He has $17, which is our initial amount. And then what do we have up here? I spied that input value, the x value, as the exponent, hence the exponential equation. And then, of course, our output is what we are solved for. Y equals 17 times 4 to the x power. So again, 17 is going to be my y-intercept. So where that line touches that vertical axis. And then our multiplier is going to be 4. All right, it's going to get 4 times greater each time. So if that b value, as you can see, we have it pointed out, is greater than 1, we are going to say that it is going to grow. All right? And that's going to look like this on a graph. Left to right, so as we go left to right and trace this, you can see how it's skyrocketing exponentially. All right? It's exponential growth. That means it multiplies really, really quickly. All right? So it's not a constant growth like we see with constant rate of change, I should say, with a line function and a linear function. This is going to have that nice curve to it, all right? Not the parabola, this is more of a curve. So this is when the b value, just to go back, that value next to the a is going to be greater than 1. So what's the opposite of growth? Is what we're going to get here is decay, and that's when this value of b is between 0 and 1. So yes, it's going to be a decimal point something. All right, that's going to be our decay value. What's that going to look like on a graph? From left to right is going very steep to almost touching that x-axis. It's not going to touch the x-axis. That's what we call the asymptote there. That's going to be a Algebra 2 word probably that you're going to get used to hearing, but it's going to approach the x-axis. It's not going to cross it like it does here, which our initial value would be 2 there. for that a value, but this value is going to be between that compound inequality, right? It's not equal to 0 because then we wouldn't have a function if it equaled 0 or equaled 1, but b is going to be between 0 and 1, so it's going to be a decimal. And you guys like decimal more than fractions, and you're going to see more decimals and fractions for that anyways. All right, so let's look at it. Growth or decay. What we are paying attention to, here's my initial value, is 10, so that's where it's going to touch the y-axis. We have that exponent as an x, that's my input, that's why it's exponential. If you look right here, is this in parentheses, is that greater than 1, 1.2? So that's going to be growth. If we look here, initial value, that's going to be my y-intercept. In parentheses, is that value greater than 1 or is it less than 1? 0.9, good. So that's going to be decay. Again, we're paying attention to the value inside the parentheses, which is greater than 1, so this is going to be growth. My initial amount's 5.2. In parentheses, that multiplier is getting less than 1, so that's going to be a decay. Here, it's doubling here too, so that's going to be growth because that's much larger than 1. And then this value, 0.07, it's close, it's approaching 0, however, not 0, and that's going to be decay. All right, so again, anything, I'm going to just circle here. These are your y-intercepts, where it crosses that y-axis, or our initial value. And then anything in parentheses is going to be that growth or decay, depending if it's greater than 1, growth, and if it's less than 1, it's going to be decay. And obviously, it has to also be greater than 0. All right, so let's look at this. Does this function represent exponential growth or exponential decay? So if we look here, in parentheses, 1 plus 0.3 gets you 1.3. So that's going to be growth because that value is greater than 1. What is our initial value? That y-intercept, remember, that's what I'm just going to put over here just to remind us where we start. That's where x is 0. Our initial value is 1200. So there's not much to it, right? We have our a and we have our b, and then we have our x and our y's. All right. What is the growth or decay factor? So the factor is what's going to be inside of parentheses. So 1 plus 0.3 gets us a growth factor of 1.03. All right, now here, the rate, all right, it's a growth rate because we already said growth. The rate is going to be a decimal turned to percent. So we have this decimal, convert that to percent, so multiply it by 100, and you get 3% is the rate. So anytime you see the word rate, that's going to be our percent. Anytime you see this factor, that's the multiplier or that b value, and we get 1.03. So you can see how these kind of correlate with one another. One's percent, one's going to be that growth factor. Factor means multiplier. This one doesn't have the 1 plus 0.03. This just says 1.25. So is this growth or decay? It's going to be growth, again, because we have 1.25 in parentheses. And when that number in parentheses is greater than 1, it's growth. What's my initial value? Or again, just to reiterate, the y-intercept, where my x is 0, 0, 100. Because that's my a value, my initial value. Is this growth or decay? This is going to be growth again. What's my factor? 1.25. I'm just going to copy what's inside of parentheses because it's already factored in there or computed for me. And then what's my rate? Anytime you see rate, remember it's going to be percent. All right? So how do we go from 1? 1 plus what? Got me 1.25. So obviously that's just adding a quarter. What is a quarter? That is 25%. We're going to move that decimal 2 spots to the right. Any questions? Again, You know the drill. Stop, rewind, re-listen. If you have a question, email. No big deal. We got your back. We want you to grow Okay, I'll stop. Exponentially, right? So let's go. We had growth. Now guess what we're going to move to? And I'm going to change it to red. Red is decay. So this is going to be decay. How do you know? Because that number inside of parentheses is 0.92, which is less than 1. So it's pretty obvious if it's growth or decay, I hope. All right. What's my initial value? Again, I'm going to reiterate the fact that this is the Y-intercept, where it crosses or touches the Y-axis. All right. That's where X is 0. All right. I can't overstate that. That's going to be 14,000. All right. Is this growth or decay? Again, it's decay. And that's going to be what's inside of parentheses. That's the 9.92. And now here's the tricky part. How do we get the rate? Because some of us see that 0.92 and say, ooh, it's 92%. Not so fast, all right? We need to say 1 minus what number, question box like Mario, gets me 0.92. All right, so this is the value we're looking for. How do we go from 1 to 0.92? All right. So real simple. You can do the subtraction, 1 minus 0.92, and you get 0.08. And now if it's a rate, we need to turn that into a percent. So again, all I did was take 1 minus 0.92 to get that box, and I got 0.08, or it's 8% decay. So this is going to be depreciating, is another word you might hear for decay, at 8% each, however long it says. So each second, each minute, each hour, each day, each year, something like that. All right. So again, the factor is what we're multiplying by, is 0.92. And then that growth rate is the percentage, and that's going to be the 0.08 that we're missing from 1. And then put that to a percent, and you get 8%. Exponential equation from a table. So here's what we have going on. They didn't show this, but we have a growth of 1 each time, 1, 1, 1. And then now we have that multiplier, right, of times 3. All right. So what this looks like as an equation, we only have really 2 parts. We have the y, the equal, and the exponent of x. Now we need to fill in the a and the b. Well, what's the a? The a is going to be the what? The y-intercept, where x is 0. So what's my initial value? 17, because that's what's paired with 0. When x is 0, that's how we're going to get that number, 17. And then what's my rate? My multiplier is 3. So it's going to look like that. An exponential equation from a table. Now here it's a little bit trickier. One, it's not a table, obviously. It's ordered pairs, but hey, we know that this is the x value and this is the y value. So we can make a table if we wanted to. However, I'm going to keep it as ordered pairs, and I'm going to erase that x and y real quick. And what we really need is what? We need the y-intercept. How do you get the y-intercept? It's where x is 0. So we need to go back 1 to the left, because if you look, we go 1 to the right with our x's, 1 to the right, 1 to the right. So we just need to go 1 to the left. How are we going from 750 to 150? How do you go from 150 to 30? How do you go from 30 to 6? We're not multiplying by a growth factor. We're getting smaller, right? So this is going to be a decay problem. So I'm just going to take, it doesn't matter. I take the last number for y, 6, and I divide it by 30. So I just took this number, put it in the numerator, take that number, 30, and put it in the denominator, and I get a multiplier of what? 1 over 5. All right? So we're getting smaller by that value. Any questions? So now, if we're dividing by 1/5 each time, or dividing by 5, multiplying by 1/5, we have to go the other way. What's the opposite of dividing by 5 or multiplying by 1/5? Good. We're going to multiply this number by 5. 750 times 5. I don't think so. Let's go right here. 750 times 5. I'm going to go backwards, right? Instead of dividing by 5, I'm going to multiply by 5. Oops. And I'm going to get, I had it up there, 3,750. So it's 0, 3,750 is going to be my y-intercept. If you recall, that y-intercept is my initial value. So when I have my initial value, I have my y here. My initial value is first. That's my a value, is 3,750. I need my decay and my exponent, which is always x. That's why it's called an exponential function. And I could either leave it as 1/5, or what is 1/5 as a fraction? I mean a decimal, 0.2. So you can either put 1/5 or 0.2. I know a lot of us like decimals, so I'm going to say that that is going to be 3,750 times 0.2 to the x power. All right, so there's that equation, and I had to go backwards to find that 0, just one spot. All right, so again, if it's tricky, you had to look for it because it wasn't there. What wasn't there? The y-intercept was not there. So I had to go back and multiply 750 times 5 to work my way backwards because it's decaying, so it's going to grow if I'm going the opposite direction, because that's the opposite of decay is growth. And we have our y equals ab to the x power. Initial value, y-intercept, there's my decay. So if you think of it, my rate of decay for this problem is actually 0.8 or 80% decay. Almost there. Write an exponential function in y equals a b x that goes through 0, 8 and 2, 288. So here's the deal. We can't just do a multiplier here because we have 0, 8, which should be like, hey, this is important. What is this? This is the y-intercept. Boom. How do you know? Because x is what? Good, 0. Anytime x is 0, we get our y-intercept. But if you notice, we skip over 1 and we go directly to 288. So 1 we could figure out probably, but let's not do that. We're going to use Desmos to help us out. But we can't just go, hey, how do we go from here to here? Because we jump by 2. So we can't figure out that multiplier. So what we're going to do is go to Desmos. We have 0, 8 and 288. So let's erase that. If you don't remember, you hit this plus sign and you go to table and you put your ordered pairs of 0, 8, and then we had 2 and 288. Here's a little secret to Desmos. It's a regression equation. All right, you type y, the number 1, and then you hit the button above tab is the tilde, and you hit the shift, A, B, because that's just my formula, and then I'm going to hit the A to the B power and get my x value. All right, and then I'm going to put 1 there, because if you look at my table up here, this x1, y1 is, there's my y1 and here's my x1. And take a look. Ready? Watch this magic. When I remove this keyboard, hide it, boom, I get my a value here and I get my b value here. So my a value is 8 and my b value is 6, and that tells me exactly how to write this equation. So again, all I did was enter my points. I hit plus, and it created a table. And then I typed in this regression equation, y, the number 1, shift the button above tab next to 1 is that tilde. I wrote in that skeleton equation, the generic equation, a times b. And then I went to my keyboard and I hit that A-B button to get to the next level. I typed in X and 1, and it gives me my information that I need. So when I go to how do I write this? Y equals, I look at my formula, A equals 8, so this is AB. My B was 6. And of course, my exponent is X. So real quick, just to go over how we did that with Desmos, to show you that, it should help you out. Desmos is your best friend. If you haven't figured that out yet, you haven't been listening to these videos. Find the equation, exponential for, again, A times BX. What's nice about this equation? What is this value right here? That is my Y-intercept, or my A value. So I have my Y equals 2 times what? What is my multiplier? Since I see it's going up by 1, up by 1, up by 1, I need to go from 2 to 6, 6 to 18, 18 to 45. If I don't see it, I can easily do the change of y's. 6 divided by 2 is 3, so it's a multiplier of 3. 6 times 3 is 18. 18 times 3 is 54. So I know my b, or my multiplier, is going to be 3. Much easier when you have the y-intercept given. Unlike this problem, I guess they did give us that. However, we found it out using that regression formula as well. Another problem that we're going to ask for you guys to accomplish is the delta math. It's going to ask you, what kind of function is this? Is it growth or decay? So if I look at the value inside of parentheses, it's larger than 1, so this is going to be growth. What is my rate? My rate is going to be this number, subtract 1 from it. So 1.55 minus 1 gets me 0.55 as a decimal. Remember, in order to convert a decimal, we just move it 2 spots to the right. That means multiply it by 100, and you get 55%. And then this is a drop down that we have to actually read, and that T stands for decades. So you would just drop down to decades. Any questions? This is what you're going to be asked to do on Delta Math, so I thought I'd go over those. Last but not least, a ball is dropped from a feet of 400, or from 400 feet. The table shows the height of each bounce. Find the height of the ball on the 5th bounce, round your answer to the nearest 10th. So if you look, they give us a lot of information here. They actually give us a secret piece of information right here. But let's pretend like we didn't understand that. But that's our starting point, right? That's where this clock hadn't started. It was 0, 400. However, let's pretend like we didn't notice that. But we have the 4th bounce and the 5th bounce that we need to add to our table. So how do we do that? All right. How do we go from 260 to 169? How do we go from 169 to 109.84? All right. We need to figure out that change of y's. So let's go. Y2 is 169 over Y1, which is 260. Type that into Desmos. What do we get? Clear that out. Clear that out. It was 169 divided by, I already forgot, 260. That's what I thought it was. Get back in the denominator. Boom. That rate of change is 0.65. So this is 0.65. So we have a decay going on here, right? Which makes sense because every time it bounces, it's going to bounce less high, less high, and less high. And let's just make sure that that is correct. And let's just do 109.85 and divide that by 169. And again, we have that constant change right there, that constant multiplier of 0.65. So now what do? We're going to take this number, 109.85, and multiply it by 0.65. We can do the long multiplication, or why do that? 109.85 times 0.65, and we get 71.4025. 71.4025. And obviously it says round to the nearest tenth. I'm going to wait to do that to my final answer. So again, I'm just going to take this number here, 71.405 or 025, multiply it again by that 0.65, and get a height of 46.411625, 41.611, and it says round to the nearest tenth. So 0.11, we're going to keep. So that final height is 41.1 feet. And we just followed that equation. Any questions, comments, concerns? Let us know. We are done with day 1 of exponential functions. I hope you enjoyed. Go Browns.